Horizontal asymptotes. The line y equals b is a horizontal asymptote of the graph of a function f if f of x, that's the y value, the function value, approaches some number b as x increases or decreases without bounds. So as x goes way out to the right or way out to the left, does the function kind of level out? That's what it means by approaching a number. The function kind of levels out there a little bit. All right, so let's look at some examples here of this. So here, we saw this same type deal with vertical asymptotes, or if you know what they are, it's very similar, except now instead of a vertical line, we have a horizontal because we're talking about a horizontal asymptote. So again, I've denoted it with this red dotted line here. Red's not important, but dotted line, typically we denote them by. So we have our function here in green coming down, and as x goes way out here to the right, it's leveling out. It's getting closer and closer and closer to that horizontal line of y equals b. Okay? So that's why we call that a horizontal asymptote. And again, I talk about the function or the graph of the function hugging the asymptote. It gets really, really, really close and keeps getting closer forever, but never touches it. That's really hard for our minds to fathom sometimes. All right, but that's what happens. As you go further and further out to the right, then, it still never touches it, but it still gets closer and closer and closer and closer. So the way we say this, as x goes to infinity, as x increases without bound, right, increases without bound, that's what this says, then the function value approaches b. So f of x approaches b. That's what that says there, right? So let's look at another image here. So then we could start above it and approach it. We could start below it and approach it from underneath, and it never crosses it, never gets there. It just gets closer and closer and closer forever, never touches it. So again, as f of x goes out here, way out here, it gets closer and closer and closer to that line b. Okay, or y equals b, because b is not a line, y equals b. And let's look at one other possibility. And you say, oh, whoa, Mr. Guest, wait a minute. You can cross a horizontal asymptote? Yep, you sure can. But if you recall, you can never, ever cross a vertical asymptote. So be careful to remember the distinction between the two. Horizontal asymptotes can cross, and in fact, in some crazy examples, you could have a horizontal asymptote to the right as x goes out to infinity without bound, and then as x decreases out towards negative infinity without bound, you could have a different horizontal asymptote. You could actually have two on the same function. So, no, we're not going to see those on this video, but they do exist. I want you to know that they're there. So if your teacher shows you one of those, don't think they're an alien. They're showing you something that's real. All right? So here, our function is, bebopping along, comes flying down here, and then, whoa, let's turn around and go back up, and then it just gets closer and closer and closer forever. And again, it approaches as f of x approaches b as x increases without bound. All right? So here, how do you find horizontal asymptotes? Now this looks hideous. We're going to talk about this. We're going to go over exactly what you're going to see in just about every math book you will ever encounter in your life, and then I'm going to tell you how I remember them. Okay? If f of x equals, and you have a sub n x to the n plus a sub n minus 1x, this is just basically in descending order. A sub n is the coefficient of the highest power or the leading coefficient. That's important, leading coefficient, all the way down to a1x, to the first, and then plus a0. And you got the same thing with b's and m's. The reason we use that is that the a sub n and the b sub m may not be the same, and n and m don't have to be the same power. Okay? So whatever it happens to be, it's in descending order, and b sub m is the leading coefficient in the denominator. So a sub n is the leading coefficient up top, b sub n, leading coefficient in the bottom or denominator. All right? Where a sub n and b sub m are not zero, that you'd be defeating your purpose, right? If your leading coefficient was 0, you wouldn't have that there. So if that's the case, then the degree of the numerator, the numerator is the top, right? The degree of the top, and if you remember, degree is the highest power, is n. And then the degree of the denominator, and that's the bottom, right? Now, we don't use those words in math, right? But that's what they are, top and bottom. The denominator, the bottom, the degree is m. The biggest power in the bottom, the denominator, is m. So I'm going to talk about the degrees, and actually, the way I do this is I look for the highest power in the whole thing. I look for the highest power in the whole thing. So I'm just going to set you up for that. So let's look at the rules here. The first rule says if n is less than m, let's think about this. N is the degree of the top. So if the highest power is in, let's see, n is less than m. That means m is bigger than n. So the highest power here is in the bottom. See, I look at highest powers. So if n is less than m, that means m, the degree in the bottom, is the biggest. So the highest power in the whole problem is in the bottom. then the x-axis, or y equals 0, is the horizontal asymptote of the graph f. If n is less than m, so the way I do that is I say the highest power is in the bottom. Okay? And I write high with a down arrow. I don't worry about n less than m and all this other stuff. I just look at the problem by inspection and go, hey, guess what? The highest power I have is in the bottom. That's how I think about this. So let's look at the next rule. The next rule says if n equals m, the line y equals a sub n over b sub m as the horizontal asymptote. Good gosh. If the two powers are the same, so the way I look at that is I say, wait a minute, the highest power is not in the top or the bottom, it's in both. So I put high equals. And if the highest power is equal, then basically I say leading coefficient over leading coefficient. You take leading coefficient over leading coefficient, and it's y equals that. Again, it's a line. It's a horizontal line, right? Horizontal line is hoi. Horizontal slope is 0. It's y equals a number. Vertical lines are x equals. That's vux. Vertical line, undefined slope, x equals a number. Okay, so for this we need hoi. Horizontal line is y equals. So it's y equals leading coefficient over leading coefficient. To me, this is the fun one. Okay, I know it's a dorky math teacher thing to say that algebra's fun, but that's the fun one. Okay, that's the one where, hey, guess what? I get to do something fun by dividing these two things. Now, the thing I want to say about this is you better simplify it. If you get 2 over 4, simplify it to 1/2. Don't leave it 2 over 4. All right, and I have some examples. So let's look at then the final rule here. Because either the highest power is in the bottom, the highest power is equal, or n is greater than m. That means the highest power is what? In the top. So the graph of f has no horizontal asymptote if the highest power is in the top. So let me go back and write my highs in here. So I have highest powers in the bottom. That's y equals 0 is my horizontal asymptote. I have the highest power is equal. That's the fun one. That's the one where, so equal. So think about equality equals is fun. Okay? I know y'all think algebra's fun. I know you don't. All right? But maybe it's funner now. That's good. Don't correct my English, please. All right? So then this one is the more fun one. High equals. That's where we take the leading coefficient over the leading coefficient and we put y equals in front of it and we simplify it. And then if the highest power is in the top, we ain't got no, we don't have a horizontal asymptote. All right? We have no horizontal asymptote. Do I have to factor to identify horizontal asymptotes? Nope. It actually makes it more difficult if you have it factored. It's better if you have it expanded, okay? So if you have it expanded, you can see the degree much more easily. Now, if it's factored, you can figure out the degree. You can say, well, if I multiply this together, it will be this. But it's much easier when it's expanded or multiplied out, simplified, however you want to say it, to find those degrees and look, where's the highest power? Because it's an inspection and kind of glance at it and see thing. All right? So I want you to note, horizontal asymptotes can be found by inspection. I already told you that. I'm going to locate the highest power and apply the appropriate rule. And I gave you the 3 rules here. The red rule, highest power is in the bottom. The highest power in the whole problem is in the bottom. The horizontal asymptote is y equals 0. The highest power is equal. The horizontal asymptote is y equals the leading coefficient over the leading coefficient. And they're respective. Leading coefficient in the numerator stays up top. Denominator in the bottom. And then the highest power is up top. You have no horizontal asymptote. All right? So here, let's go ahead and, in fact, let me go ahead and put me some boxes down here for horizontal asymptote. Let's see what we got here for these things here. All right? So if we look at the first one up here, as I write these on here, we get f of x equals what? F of x equals 15x over 3x squared plus 1. All right? So here, where is the highest power? Well, first of all, the highest power is what? 2. 2 is the highest power, and where is it? In the bottom. And my rule for highest power in the bottom says y equals 0. There is no work. This is inspection. If I tell you on my test, if you took my class and I said, show your work, and you say, Mr. Guest, y equals 0, and I say, where's your work? You say, there is none. And you're right. I mean, I guess this would qualify as work. You're telling me what rule you're using. Okay? That would be what I'd want to see high in the bottom so I'd know where you got that from. Or either the N and M business. Okay? So then what about the next one? Well, here, the highest power is 2. And guess what? It's in both places, so we call that the high is equal, right? And so how do I do that? I say y equals leading coefficient, 15 and 3. So 15 over 3. No, I just blindly put that in the answer? No. 15 over 3. 3 goes into 15 perfectly. It divides into it how many times? 5. So this is going to be what? Y equals 5. If you just write 5 in the blank, my pen will explode on your paper if you're in my class, okay? Your teacher will likely count off because horizontal asymptotes are lines, therefore they must have the y equals, okay? So then if we keep bebopping along here to the next one and we get over here and we say, okay, highest power is what? 3, and it's where? Notice I'm giving you one of each here, right? Highest power is up top. Highest power is up top. If it's up top in the numerator, then we say none here in A, okay? And then the final one here, the fourth one here says, okay, the highest power, look, is 1. It's in both places, right? So here, and of course I'm going to give you the fun one twice, right? The highest power is equal. So how do I do that? Well, I say y equals the leading coefficient. Now, you got to be careful. The leading coefficient just means the coefficient of the highest power if it's in descending order. It's still the coefficient of the highest power, so it might not be in descending order, but these are, just be careful, I want to caution you of that, -3 over 5. Okay, so then -3 over 5, and typically speaking, when we write this, we say y equals, and we bring the negative out front when it's one term over one term. Okay, y equals -3/5, and there's nothing to simplify there. You can't simplify that anymore like we could the 15 divided by 3 over here in blue. All right, so there's horizontal asymptotes. Again, I narrow it down to where the highest power is, and then I know my rules from that. If you want to learn all the N's and M's and all that business, that's fine as well, because that is the proper way to do this. So